Hi, in the last video we have discussed the quadratic expression and its roots, how to find the roots of quadratic equation, the relation between the roots and the coefficients, and finally we discussed some of the results which is very important for JEE Mains and JEE Advanced. In this video I am going to discuss the nature of the roots, what is the nature of the roots, how a quadratic equation represents a parabola, and how to find maximum minimum value of a quadratic expression. These 3 points we are going to discuss in this video. Let's start the class. In the last video we discussed the roots of quadratic equation are x is equal to minus b plus or minus root over b square minus 4ac by 2a, b square minus 4ac by 2a. Right. Here, this b square minus 4ac by 4ac is particularly represented by delta. This value is equal to delta we call discriminant. Discriminant. With the help of this discriminant, nothing but delta, we can decide whether the quadratic equation has real roots, whether they are equal or distinct or complex roots, whatever we can find the nature of the roots with the help of this delta. This delta is called discriminant. Its value is b square minus 4ac. Nature of the roots can be divided into 2 cases. Case 1, case 2. Case 1. Case 1. In case 1, a comma b comma c are real. A comma b comma c are real. In the same way, in case 2, if a comma b comma c are rational numbers. Here you should remember one point. Every rational number is a real number, but every real number need not to be a rational. For that aspect, here we have 2 cases. First come to case 1. Already we discussed nature of the roots will decide with the help of delta. First point, if delta equal to 0, roots are real and equal. Real and equal. Second point, if delta is greater than 0, roots are real and distinct. Distinct in the sense different roots, both roots are different. Third point, if delta is less than 0, roots are non-real complex numbers. Non-real complex numbers. That means roots must be in the form of alpha plus or minus I beta. Alpha plus or minus I beta. Now come to second case. Here A, B, C are rational. Here also we have subpoints. First 2 points. If delta equal to 0, roots are rational and equal. See the difference. Rational and equals. Second point. If delta is greater than 0 and perfect square, that must be perfect square, then roots are rational and distinct. Rational and distinct. Third point, if delta greater than 0 but not perfect square, in this case roots are conjugate surds. Conjugate surds in the means roots must be in the form of alpha plus or minus root beta. This form we can take conjugate surds. Fourth point, if delta less than 0, it's the same as case 1 point. Roots are non-real non-real complex numbers. Non-real complex numbers. That means roots are in the form of alpha plus or minus I beta. So these are the two cases will decide nature of the roots of a quadratic equation. Sometimes, particularly in the mains and midsat, that kind of exams, there are options to decide whether the roots are rational or roots are rational. We need to follow these steps. If the delta greater than 0 and it is a perfect square, in case delta greater than 0, it is a perfect square, and there is an option, particularly roots are real and distinct or roots are rational distinct. We need to choose roots are rational distinct. You need to follow these points. Now, I am going to explain how every quadratic expression or equation represents a parabola. What is the relation between the parabola and the quadratic expression? But before going to start, we need to talk about two basic parabolas. Generally, we know that total number of forms of parabolas are roughly 8. 4 are related to vertex 0, 0, remaining 4 are vertex shifted from h, 0, 0 to h, k. So out of these 8 forms, I am going to discuss only 2 forms, which are x minus h whole square is equal to 4a into y minus k, and second thing is x minus h whole square equal to minus 4a into y minus k. I want to explain brief about these two curves. First, take x minus h whole square equal to 4a into y minus k. Definitely it represents a parabola. The parabola may be like this. Like this. It means the parabola opens upwards when a is positive. For this, the parabola may be like this. It means when a is negative, parabola opens downwards. So these two things are important for us to explain how ax square bx plus c represents a parabola. First of all, take that y is equal to ax square plus bx plus c. Now take a common, you will get x square plus b by ax plus c by a. Now y is equal to a into x square plus multiply with 2 and divide with 2 for this particular term plus c by a. Now adjust this as a perfect square, x square 2 times of b by 2a x plus b by 2a whole square minus b by 2a whole square plus c by a. From here to here, this is y is equal to a into x plus b by 2a whole square minus b square by 4a square plus c by a. So that is y is equal to a into x plus b by 2a whole square. By simplify this, we will get 4ac minus b square by 4a square. Now multiply with a, you will get y is equal to a times of x plus b by 2a whole square plus 4ac minus b square by 4a. We can adjust this is x plus b by 2a whole square is equals to 1 by a times of y minus 4ac minus b square by 4a. 4ac minus b square by 4a. So it is in the form of x minus h whole square is equals to 4a into y minus k. You can clearly observe this. The curve what we got, x plus b by 2a whole square equal to 1 by a into y minus 4ac minus b square by 4a is in the form of x minus h whole square equal to 4a into y minus k. We can easily say here vertex. What is vertex of this parabola? Minus b by 2a comma 4ac minus b square by 4a. Right? So for that we can say every expression, quadratic expression ax square plus bx plus c represents a parabola. This parabola shape will decide by 1 by a. If a is positive, this parabola opens upward. If a is negative, this parabola opens downward. So every quadratic represents a parabola. Its equation is x plus b by 2a whole square equal to 1 by a into y minus 4ac minus b square by 4a. So its vertex is vertex h comma k. By comparison, you can say minus b by 2a comma 4ac minus b square by 4a. We can write this is as minus b by 2a comma minus delta by 4a, because already we discussed delta value is b square minus 4ac. So here we have 4ac minus b square. By taking minus common, we get delta. So vertex of this parabola is minus b by 2a comma minus delta by 4a. Right. With the help of this, we can easily identify the extreme values of quadratic expression. Here the extreme values in the sense maximum value or either minimum value. If a is positive, the parabola may be like this. Like this. Let's take this is y-axis and take this is x-axis. For example, 0. Here, this is the vertex of the parabola, right? That means this is the vertex of the parabola. So this value is x is equal to minus b by 2a. Okay. This value is x equal to minus b by 2a, and this value is 4 is minus delta by 4a. Right? So here we get the maximum. Here we get the minimum value of the parabola. Minimum value, because compared to these values, we will get least value here. So when a is greater than 0, for quadratic expression, we will get minimum value. That value is y minus delta by 4a. This is the minimum value. Okay, right. If a is less than 0, let's say x-axis, y-axis, origin, parabola may be like this. Right. This is the vertex of the parabola, right? That is the vertex of the parabola. So, right. So this is x is equal to minus b by 2a, and this is the minus delta by 4a. It is very easy to understand. Compared to these positions, this is the top. Compared to these 2 points, this is the highest point. So when a is less than 0, you will get maximum value of the parabola. That is also same minus delta by 4a. So briefly, every quadratic represents a parabola already we discussed. The vertex of the parabola is minus b by 2a comma 4ac minus b square by 4a. Simply we can write minus b by 2a comma minus delta by 4a. When a is greater than 0, the curve may be like this, depends on the parabola concept. So by observing this compared to these points, this is the least point. So we get minimum value here. What is the minimum value? Minus delta by 4a. At where x equal to minus b by 2a. The same way, when a is less than 0, the curve may be like this. So compared to these 2 points, this is the maximum point. So we get maximum value here. Maximum value here. Okay. Maximum value here. At where x equal to minus b by 2a. What is the maximum value? Minus delta by 4a. Nothing but 4ac minus b square by 4a. Right. Here we have another method also to find extreme values of quadratic expression based on the second derivative test. Right. First come to the explanation. Let f of x is equal to ax square plus bx plus c. Find f dash of x. According to derivative formulas, x co-derivative is 2x, so 2ax. Derivative of bx is b. Derivative of constant is 0. Again derivative of this, you will get f double dash of x is equal to 2a, because derivative of x is 1, derivative of constant is 0. Right. Now, if a is greater than 0, okay, if a is greater than 0, very clear, f double dash of x is also greater than 0. In the same way, if a is less than 0, here f double dash of x is also less than 0. So depends on the a value, f double dash of x nature will change. Now come to the second derivative test. What is second derivative test? If in case f of x is a polynomial function, and f dash of x is equal to 0 when x is equal to a, and f double dash of x is positive, f of x has minimum value at x is equal to a. F double dash of x is negative. F of x has maximum value at x is equal to a. So this is the second derivative test. Now it is very clear to observe here when a is greater than 0, f double dash of x is greater than 0. Right. Now make f dash of x equal to 0. What you will get? 2ax plus b equal to 0. From here what is a value? Minus b by 2a. So at a is equal to minus b by 2a, at a is equal to minus b by 2a, a is positive, f double dash of is greater than 0. When f double dash is greater than 0, according to second derivative test, f of x has minimum value. So we conclude that when a is greater than 0, it has minimum value. When a is less than 0, it has maximum value. How we can say? See, it's very clear. When a is less than 0, f double dash less than 0. F double dash of less than 0, f of x has maximum value. I hope you can understand. At final, we can conclude the first point. If a greater than 0, ax square plus bx plus c has minimum value, at where x equal to minus b by 2a. What is the minimum value? 4ac minus b square by 4a. We can write minus delta by 4a. Now the second point is, if a less than 0, ax square plus bx plus c has maximum value at where? Same position, x equal to minus b by 2a. What is the maximum value? Same value, that is 4ac minus b square by 4a. Nothing but minus delta by 4a. At final we can say ax square plus bx plus c extreme value will decide based on the a value. If a is positive, expression has minimum value. If a is negative, expression has maximum value. Please keep these points.